Hello everyone! Welcome to Teacher Hanji's channel. For today's tutorial, our lesson is to illustrate the law of sines and use the law of sines to find the missing parts of the given oblique triangles. Now, let's begin. First, let us define what is an oblique triangle. Remember that an oblique triangle is a triangle in which there is no right triangle. Oblique triangle includes an acute triangle in which it is a triangle with all its angles acute. And aside from acute triangle, another oblique triangles are the obtuse triangles. This is a triangle with one obtuse angle. In solving oblique triangles, at least the measure of one side and any other two measures, the angles or the sides, or the combination of these must be given. There are four possible cases of oblique triangles. The first case is given the two angles and one side, which are the ASA or SAA. Second case, we have given the two sides and an angle opposite to them or the SSA. And for the case 3, we have given two sides and the included angle, which is the SAS or SAS. And for the fourth case, we have given the three sides, which is the SSS. In second case, it is sometimes described as ambiguous case because it is possible that the solution of this case is not a unique solution or there are two solutions or no solutions at all. One property of triangles that can be used in solving oblique triangle is embodied in the law of sines. So this time, let us define what is the law of sines. Remember that the law of sines states that in any oblique triangle, any two sides are proportional to the sines of the opposite angles. So let us consider triangle ABC here. Always bear in mind that in any triangles, we must know how to name the given sides of the given triangles. Since in the law of sines, we will use the proportion of the two sides to the sines of the opposite angles. So in this case, let us have first the ratio of the sides to the sines of the opposite angles. So let us have the sides opposite to our angle A here. So we have here these sides and let us name it a small letter A. Therefore, our ratio for this one will be A over sine A. This time, let us refer to angle B. If we notice, angle B has this opposite side. Therefore, these sides can be named as small letter b or side B. And as for the ratio of these sides to the sine of this opposite angle, it will be B over sine B. For the last angle, which is angle C, in which the opposite side is this one, then we will name it as small letter c, or this side will be the side C. So the ratio for this one will be C over sine C. And since in the law of sines, there are two sides that are proportional to the sines of the opposite angle. So it means A over sine A is equal to B over sine B, while B over sine B is equal to C over sine C. Or it can be written as sine A over A is equal to sine B over B is equal to sine C over C. Please remember these proportions as we will use these equations as we solve for the missing parts of the given oblique triangles. So let us have the following examples of an oblique triangle using the law of sines. Let us have the first one. In triangle ABC, A is equal to 16, measure of angle A is equal to 40 degrees, measure of angle B is equal to 58 degrees. Let us find the length of side B, side C, and the measure of angle C. So let us draw first this triangle ABC, in which, in this triangle, the opposite side of angle A here will be named as side A here, while the opposite side of angle B here will be named as side B. And the opposite side of angle C here will be named as side C. Now that we named the side of these oblique triangles as well as the angles of these oblique triangles, let us now have the given. According to this, in triangle ABC, the length of side A here is equal to 16, while measure of angle A, which is this one, is equal to 40 degrees, and measure of angle B is equal to 58 degrees. Our task now is to find the length of side B, the length of side C, and the measure of angle C. So this time, let's begin. Let us start first with finding the measure of angle C. Since we know that in any triangle, the sum of the measures of each angles should be equal to 180 degrees. Therefore, we can say that the measure of angle A plus measure of angle B plus measure of angle C should be equal to 180 degrees. And since we already know that measure of angle A here and measure of angle B here are given, then for us to get the measure of angle C, let us find the difference between 180 degrees and the sum of the two given measures here. Therefore, 40 degrees plus 58 degrees is equal to 98 degrees. With that, measure of angle C is equal to 180 degrees minus 98 degrees. Subtract these two. Therefore, measure of angle C is equal to 82 degrees. Then, this time, let us find the length of side B. Since this is an oblique triangle, with the measures of angles here are given, as well as one side of this triangle. Therefore, to solve for the length of side B here, let us now use the law of sines, in which it says that A over sine A is equal to B over sine B equal to C over sine C. In this case, we will just pick two ratios that are proportional to one another. According to the given, the length of side A is given here, while the measure of angle A is also given. Then, we may use A over sine A as our first ratio. For the second ratio, let us have B over sine B. Why? Because we are asked to find the length of side B. Therefore, in our case, we will be using A over sine A, which is equal to B over sine B. Let us substitute the length of side A, measure of angle A, and measure of angle B. Therefore, we will have 16 over sine 40 is equal to B over sine 58. Let us use cross multiplication so that the denominator here will be equal to 1. Simply multiply sine 40 times B and sine 58 times 16. Therefore, we will have sine 40B is equal to 16 sine 58. So to isolate B here, let us divide both sides by sine 40 so that sine 40 over sine 40 here will be equal to 1. And as for the length of side B, using your scientific calculator, please press 16 sine 58 divided by sine 40. Let us round off our answer to the nearest hundredths. Therefore, the length of side B is equal to 21.11. And this is the length of this side. Next, let us move on with finding the length of side C. In our past lesson, when the length of the two sides are given, then for us to get the third side, we simply use the Pythagorean theorem. But remember that Pythagorean theorem is only applicable for any right triangle. And since we are now dealing with oblique triangles, then we will use again the law of sines. In this case, we will use C over sine C here since we are asked to look for the length of side C. And as for the ratio proportional to C over sine C, just decide which among these two will you use to get the answer. Since we already know the length of side A and the length of side B. We also know the measure of angle A and the measure of angle B. But for my case, let me use the first ratio and the last ratio. Therefore, our proportion will be A over sine A is equal to C over sine C. Same with what we did a while ago, let us simply substitute the length of side A, measure of angle A, and the measure of angle C that we obtained a while ago. Therefore, we will have 16 over sine 40 is equal to C over sine 82. Once again, let us cross multiply so that the denominators here becomes 1. Therefore, we have sine 40 times C and sine 82 times 16. And this one is equal to sine 40C is equal to 16 sine 82. We are asked to find the length of side C, so that to isolate C here, let us divide both sides by sine 40. And using scientific calculator, let us compute for the length of side C. Press 16 sine 82 divided by sine 40. Therefore, the length of side C is equal to 24.65 to the nearest hundredths. And this is the length of this side. Now we already completed the lengths and measures of these oblique triangles. Let us try another example. Example number 2. In triangle PQR, measure of angle Q is equal to 98 degrees. Length of side Q is equal to 22 and the length of side P is equal to 13.7. Let us find the measure of angle P, measure of angle R, and the length of side R. Once again, let us draw a triangle that illustrates triangle PQR. Next, let us name the side of this triangle. Since we have here angle P, then the sides opposite to it will be named as side P. Since we have here angle Q, then the opposite side to it is named as side Q. And for angle R here, let us name the side opposite to it side R. From here, let us input the given in this problem. It says here that measure of angle Q is equal to 98 degrees. Therefore, this angle is equal to 98 degrees. It also says here that the length of side Q is equal to 22. Therefore, this side is equal to 22. And the length of side P here is equal to 13.7. And we are asked to find the measure of angle P, measure of angle R, and the length of side R. This time, let's begin. Let us start first finding the measure of angle P. If you notice in our oblique triangle, we only have measure of angle Q here. Unlike with the first example, there are two given measures, therefore we simply get the difference between 180 degrees and the sum of those two measures to find the measure of the third angle. But in our case here, we will use the law of sines to find the measure of angle P. Therefore, our proportion will be P over sine P is equal to Q over sine Q equal to R over sine R. So in our case here, let us decide which proportional ratios will we use to find the measure of angle P. Again, we are looking for the measure of angle P, then the first ratio that we must have is P over sine P. And as for the given, it says here that the measure of angle Q is equal to 98 degrees while the side opposite to it is equal to 22 units. Therefore, let us use this proportion. P over sine P is equal to Q over sine Q. Let us substitute the length of side P, length of side Q, and the measure of angle Q. Therefore, we will have 13.7 over sine P is equal to 22 over sine 98. Let us cross multiply sine P times 22 and sine 98 times 13.7 is equal to 22 sine P is equal to 13.7 sine 98. Therefore, let us isolate sine P here by dividing both sides by 22. With that, 22 over 22 will be equal to 1. While using scientific calculator, let us look for the value of sine P. 13.7 sine 98 divided by 22. Therefore, sine P is equal to 0.6167. So we are asked to find the measure of angle P. Therefore, using your scientific calculator, let us find the angles whose sine value is equal to 0.6167. Simply press Shift, Sine, 0.617 for us to get arc sine 0.6167. Therefore, the measure of angle P is equal to 30 degrees. So we already found here the measure of angle P. Let us now move on in finding the measure of angle R. Since we have here the measures of these two angles, and we know that the sum of measure of angle P, measure of angle Q, and measure of angle R is equal to 180 degrees, then for us to get the measure of angle R here, let us simply find the difference between 180 degrees and the sum of measure of angle Q and measure of angle P here. Therefore, 98 degrees plus 30 degrees is equal to 128 degrees. Measure of angle R is equal to 180 degrees minus 128 degrees. Subtract the two, then measure of angle R is equal to 52 degrees. We already completed the measures of the angles of these oblique triangles. This time, let us have the last one. Let us find the length of side R using the law of sine. Since we are asked to find the length of side R, then we will use the ratio R over sine R. We already know the length of side P and side Q. We also know the measure of angle P and the measure of angle Q here. Therefore, we may choose any of these ratios to be equal to R over sine R. But for my case, let me use this proportion in which Q over sine Q is equal to R over sine R. This time, let us substitute the length of side R, measure of angle Q, and measure of angle R. Therefore, we will have 22 over sine 98 is equal to R over sine 52. Cross multiply sine 98 times R and sine 52 times 22 is equal to sine 98R equal to 22 sine 52. So again, we are asked to find the length of side R. Let us divide both sides by sine 98. And using your scientific calculator, let us now compute the length of side R to the nearest hundredths. Press 22 sine 52 divided by sine 98. Therefore, the length of side R is equal to 17.51. Remember that we can use the law of sines to find the missing parts of an oblique triangles. That's it for our tutorial. Thank you for watching. Hope you learned something today. See you again in my next video. Bye!